All right, so the final type of problem I want to discuss with parabolas is how to write the equation of a tangent line to a parabola. So remember, the tangent line is a line that crosses or touches an object or a graph at a single point, which we call the point of tangency. And with parabolas, what's unique about the tangent line is that the distance from that point of tangency to the focus, so let me just go ahead and draw that. The distance from the tangent line to the point of tangency, I should say, to the focus. Let me make that a little bit more clear. Okay. And if we were to call that distance d1, for example, and I were to also draw that same distance from the focus down the axis of symmetry, and we call this here d2. d1 is equal to d2. In other words, these are congruent lines. Okay. So to say again, the point of tangency, the distance from the point of tangency to the focus, is equidistant to the point that we call the focus down to the axis of symmetry. And that's where it's going to cross that tangent line again. So we have a little bit of like this isosceles triangle here. So we're going to leverage that bit of information to help us figure out that point of tangency. The key in this problem here is to try to figure out what this point is, because we're likely going to be given our point of tangency, and hopefully we were able to figure out where our focus is. But if we could figure out where this point is, where that tangent line crosses our axis of symmetry, then we have the 2 points necessary to write the slope-intercept form, or just the equation for the line for the tangent line. So let's try this with a problem here. So let's find the equation of the tangent line to the parabola x squared is equal to 2y at the point 3, 4.5. So the first thing that we're going to need to do is we're going to need to find out some information about our parabola. So get parabola. Let's see, get parabola information. Get parabola info, like whatever we can glean from our equation. So first off, I notice that my x term is squared. That means my parabola is going to be opening vertically, either opens up or opens down. And the fact that our 2 here, let me actually just rewrite this here so it's a little bit larger. We know that this coefficient of 2 represents our 4p, because again, it's x minus h squared is equal to 4p y minus k. This is the standard form equation of a parabola. And so since that 2 represents 4p, I can say 4p is equal to 2. That means p is equal to 1/2. And since this p-value here, let me just do this. Since this p-value here is positive, it's greater than 0, since it's positive, I know that my focus is going to be above my vertex. So based on the standard form equation that we have here, ask yourself, where is my vertex? Well, I see that both h and k are equal to 0, so my vertex has to be at the point 0, 0. And since, again, my p-value is positive, I know that my focus is going to be above my vertex vertically. So this is going to be 0, 1/2. Okay, so let's actually take a moment and just graph those points here real quick. So I have 0, 0, there's my vertex. That's the lowest point of my parabola. My focus is going to be right above it, so I'll just label it as such. There's my focus, there's my vertex. And what else do we know? We were given in the problem, the point of tangency is going to be 3, 4.5, which is right around here. And since it's symmetric about our axis of symmetry, I can then just go ahead and graph another point here at -3, 4.5. And normally I would want you to graph more points for our parabola, but for what we're trying to do right now, we're just trying to get a rough sketch of what the parabola looks like anyway. So let's just do something like that. Okay. So we actually are able to get a pretty decent amount of information from that. Oh, and no, I think we got everything. All right, so we know it opens upward. So the next thing that we're going to do, let's find this D1 value. Let's find D1, okay? What is that? And let me draw this again in the same color. So D1 is going to be the distance from that point of tangency to our focus. Okay, so this point here was 3, 4.5. So the distance from the point of tangency to our focus. Well, how can we find that distance? Well, the same way we'd find any distance of a line segment, we were just going to go ahead and use the distance formula. So d1 is equal to the square root of 3 minus 0 squared plus 4.5 minus 0.5 squared. All I'm doing right now is the distance formula between these 2 points, my point of tangency and my focus. And that's going to give me, what is that, 3 squared, which is 9. 4.5 minus half is 4 squared, which is 16. The square root of 25 is just 5. So there's my d1. So this is a nice clean integer. What that means now is that right around here, okay, in other words, the distance from my focus down to where this tangent line is going to intersect my axis of symmetry, this is going to be equal to 5 as well, since they have to be congruent. Okay, so let's actually write that. So we can say, find D2 intersection. Where is that tangent line, again, going to cross? And I haven't drawn the tangent line yet, so now would be a good time for me to do that. So let me draw that tangent line. So what we're saying in this problem, and I haven't drawn this perfectly, but what we're saying in this problem is that here, this tangent line, again, not great, sorry, this tangent line is going to intersect my axis of symmetry at this point, D2 units down from where the focus is. So let's find that. So that D2 intersection, where was that? We said if I know that my focus was 0 and 1/2, that means if I subtract 5 from 1/2, then that's going to be this point down here, right? Down here, that's that point. So that would be 0, negative 4.5. So this point here turns out it matches out really well. That's 0, negative 4.5. So I've got 2 points now on my tangent line. I've got the original point of tangency as it was given, and I've got the point where the tangent line intersects the axis of symmetry, which was D1 or D2 units away down from the focus here in this particular case. So my last step now is just to write the tangent line. So in order to write the tangent line equation, I'm going to need my slope, which is just us using the slope formula. So m is equal to 4.5 minus negative 4.5 over 3 minus 0, and that's 9 over 3, which is 3. And since we already have a y-intercept in this case, if we didn't have the y-intercept, we would just use point slope form and simplify. But we can just say then y is equal to our slope, 3x, and our y-intercept minus 4.5. And there is our tangent line equation. Okay.